Okay, so let's continue with the topic that we have today, that is emission in petroleum industries. So table 1.3, 1.4 and 1.5. So this is table 1.4. No, table 1.45 are down below. Okay, gather all the average emission factors, synthetic, organic, chemicals, manufacturing industries, that is SOCMI factors are used to determine equipment leak, emission from chemical factories or plants or chemical processes within refineries. These factors are for TOC, total organic this compound emission rates. Emission factor for major atmospheric pollution in refinery is given in table 1.4. Refinery factor are used to determine equipment leaked, fugitive emission from a refinery process for a chemical process located within a factory, within a refinery, that is not especially considered a refinery process. For example, an MTBE production units, the SOCMI factor must be used rather than refinery factors. So these factors are non-methane organic compound emission rate. So let's see table 3 first. Emission factor for synthetic, organic, chemical industries. So for synthetic, organic, chemical industries, we have to see these SOCMI emission factors. Like, what are the emission factor of from bulbs, pump seal, agitators, seal or compressor seals, pressure relief bulbs, connectors, open-ended lines, sample connection. So every connection might have some leakage, and it's about air, and air can escape from any places, any small place in the bulb or anything, So example calculation: assuming a process operating gaseous products, calculation of fugitive emissions can be done like following. Data, for example, calculation are given in table 1.6. The below formula are used to calculation to obtain this. So these are the refinery average emission. Okay, so for refineries we use this data of emission factors. And in table 1.5, oil and gas production operation average emission factor. So this is for oil and gas production, and there is some formulas, given data and 7 calculated result. Okay, given data, for example, so this is the data and this is the result. Table 6 and table 7, what it says, let's say table 6 data, for example. So table 6 has data and table 1.7 has the result obtained from this formula and all this. Okay, so VOC emission rate equal to equipment count into weight fraction into emission factor, which we have already known. Total VOC emission equal to sum of VOC emission rate into hour of operation. Total TOC fugitive emissions from a unit process can be known by summing emission from each type of component from each stream. Average factors generally determine total hydrocarbon emission. In order to determine total VOC emissions, the calculated emission rate must be multiplied by the stream weight percentage of VOC compounds. Indeed, it can happen that not all organic compounds represents in the stream be classified as VOCs. For instance, methane or ethane. So given data, so this is the data. So we have equivalent count for bulbs is 272, whereas compressor is 3, relief bulb is 37, and open-ended lines are 489, and sample connection is 24. So how many hour per year? So it's hour per year. It is this much hour per year, and this is the weight fraction, VOC weight fraction. Now we calculate this into this plus this, okay, na, right? Or equivalent count into weight fraction into emission factor. So all fraction, weight fraction, weight fraction into emission factor. What we are doing is we are multiplying everything. I think so. We have this formula here. Yesterday we talked about that formula. So if we have forgotten, we had this formula here somewhere. So all into it. So multiplication of every data, we get the result. So these are the result. Total VOC emission T per year. Emission. So emission is given by T. What is T? T per year. Time per year? What is T? Let's not go into it. Okay, we might find later in this chapter. In some of the organic compounds in the stream are not satisfied as VOC. Total VOC emission can be calculated with the following formula. So there is another formula if VOC is not classified. So ETOC into WP VOC divided by WP TOC. VOC, the VOC mass emission of equivalent TOC, the TOC mass emission concentration of equivalent in weight percentage, concentration of equivalent in weight percentage. If for the stream estimating emission for a specific VOC in the mixture of is necessary, then we use this. So if there are different kinds of chemicals, then we use especially X, chemical X. Three other methods emitted from the protocol for equivalent leak emission estimate are available. However, this method necessitates on-site monitoring, so they are not included in the scope of the studies. The following process emission sources are discussed here: vacuum distillation, catalytic cracking, thermal cracking process. Following process emission sources are discussed here. Yeah. However, these methods are necessary on site monitoring. They are not included in the scope of this study. Three other methods. Okay, so there are other three methods, and it can be done on site. So they are not included as it is not the scope of this study up now. Let's say I will grow eventually. So what process emission sources has been discussed are as follows. So there is only theoretical explanation to all it. That is vacuum distillation, catalytic cracking, thermal cracking process, utility boilers, heaters, compressor engines, blowdown system, sulfur recovery, etc. We'll learn this one by one in this other video. Thank you for watching. See you in another video. Bye bye. Take care.